Ladies and gentlemen, I'd like to walk you through a little story that happened to me very recently. A few months ago, I was just walking back home, actually, and back to my place. And like every day, I wanted to take my elevator to go back to my flat. So I pressed the elevator button, and when I pressed the elevator button, it doesn't work. It didn't work. It was not working for some reason. So I said, well, I'm going to have to climb the stairs like we all do, right? So while climbing the stairs, I called the elevator maintenance guys and I asked him, why is the elevator not working actually? What's happening? He told me it's not connected to internet. I said, what? Why would my elevator need to have internet access to work, right? Are there people downstairs in the machinery waiting for their TikTok entertainment system to kick in and bring me up or what? He said, no, obviously not, right? I think we all here know that elevators are more and more connected, and they are required to have various information sent back to servers, cloud servers, for maintenance, preventive maintenance, monitoring, and also for the emergency calls. So as the elevator saw it didn't have internet access, it puts himself in a safe mode and wasn't working. So I said, okay, then, well, I climbed back the rest of the stairs and came back home. And then I asked myself, but wait, is it actually safe to have my elevator to be connected to internet? Is it a safe way to have this device that is a security device, physical security device, to be connected? And indeed, as I just said, it's the question I'm going to try to answer today. The question is internet actually suitable to use as a backhaul for IoT devices? So I'm Sylvestre, as just said. You may have heard my accent, I'm French, and I'm here really happy today to answer this question with you and discuss that. We tend to use IoT devices and trust them for data. So there is a lot of regulation put in place. For data, it should be fine, but for physical security, it's maybe something we should discuss. Can we trust IoT devices for medical devices? Can we trust it for transport, for elevator, for instance? And whenever it comes to this physical question, this physical security, is it a right way to do it? We all have heard about the various examples, and I'm going to walk you through why internet, I believe, should not be connected, IoT devices should not be connected to internet. Maybe see a few alternatives we can have about that. And I'm going to introduce you to a product we have in Console Connect. Console Connect, by the way, if you don't know us, we are an interconnection platform. We connect people, we connect businesses, we connect networks, IoT devices as well, and we try to do it in as secure and automated way as possible. So I'm going to talk about this HSIM product, not too much into detail. If you want to have more information about that, we have a booth, we can give you a demo, show you, and answer any kind of questions. I'd rather spend a bit more time on the use cases that we went through on that specific topic. So before even starting with that, I just wanted to share a few examples of devices that have been hacked. You may have heard about that, and I want to start with this funny one. It's the unsecured CCTV Twitter account, where you can find CCTVs, video cameras on internet that have been hacked, and this account is publishing pictures of people that have no idea about it. So that's maybe one of the problems. You may have heard about the Nest thermostat example as well in 2019, where those thermostats have been hacked, and hackers were able to tamper with the temperature, put it to freezing. Again, I think it's something that we need to think of, why and how to handle that. There was this famous also Verkada hack. Verkada is a company that is providing video security, and Verkada were hacked, and hackers were able to access to footages on quite private places like prisons and hospitals. Again, something we need to think of. Something a lot of us talking about is the EV chargers, right? A few years ago, that was back in 2021, some researchers of the University of San Diego in California found security vulnerabilities to hack the specific Juicebox Pro EV chargers. And they were able to tamper with the data of this specific Juicebox EV chargers, and maybe also sometimes stop the charging, put it back on. You can imagine what would happen if thousands of EV chargers suddenly would be put on, the public power grid would just fall down, which is, again, going back to this physical issue that we have. But to me, the most threatening one is medical devices. What was last year in 2022, where insulin pumps were able to be hacked, and the hackers were able to tamper with the dosages. So no harm happened there, but you can imagine what could have happened. So again, I want to question if internet should be this backhaul to connect the IoT devices back to the servers that are rendering the actual service. And maybe we should ask ourselves first, why is it actually used in the first place? Why is it used today? Well, I see at least 4 reasons for that. The first one being that the cloud servers are connected to internet. So it's make it obviously easy to connect to the cloud servers through internet. Standardization would be the second one. The second reason, IP is ultra standard and we love all of us to use IP for that. And the GSMA standardized radio access technologies are standardized as well. So this altogether make the internet put together with the cellular connectivity a ubiquitous way to connect IoT devices. Well, price effectiveness could be also one of the reasons. I want to make sure we all understand what we mean by price effectiveness here. Wait for the cloud providers to send you the egress charges. Wait for you to be able to have all the security equipments in place to secure things. And maybe price effectiveness is not anymore that much of a reason. And anyway, I believe really that internet is a bad practice to connect IoT devices, right? And Etsy, by the way, provided some recommendation, mandatory one and more recommendation level. One of them being to minimize the exposed surface attack. So there's this specific Etsy EN 303.461 465, sorry, that has been put out here. And they really recommend to disable the unnecessary interface, network interfaces, as well as only enable those services that are really required. Basically, I believe this is a clear call to bypass internet as a mean to bring back the data from the IoT devices to the servers. So maybe we should now ask ourselves, what are the alternatives to this backhauling through internet? Well, one option would be, obviously, to use to use edge computing. Some other tracks are talking about edge computing, but obviously the less you have data that is flowing to the cloud servers, the less the device is connected. So at some point, you don't call it connected anymore. It will bring some good things, but something that is not connected is basically not connected. At the other side of the spectrum, we could think of end-to-end private networks. So the radio access technologies, as well as the connection to the cloud servers, would be completely private. That would be an option, indeed. In some close places here, I have a picture of a plant. That would be an option, maybe. But it lacks ubiquity, right? You can't have it everywhere, really. So maybe you can find some sort of, I would say, hybrid approach, right? Where you could have some part that is private, some part that is, let's say, more public. But before going into that, maybe you need to ask yourselves various questions with regards of how do you change your public cloud provider? How do you actually want to be stay able to change this? So how would you change your public cloud provider? How would you actually also migrate existing IoT devices? You may have go through an acquisition and then you need to manage this existing devices out there and again change your public cloud provider. The scale up is obviously a big issue when you're scaling up to millions of devices. How are you going to do that with all those security equipments that you want to put over internet? Another question that you need to answer is the data sovereignty. We have more and more regulations around data sovereignty, especially in the EU, but everywhere in the world. So sometimes you need to make sure the data is stored, and even on transit, you need to make sure that the data doesn't cross, I would say, unfriendly countries or embargoed countries. So again, internet, you never know where the traffic goes and where it's going through. Sometimes VPN is one of the options that I hear. And again, when we are talking about IoT devices that are constrained on CPU level or on battery power level, how do you input VPNs? So at Console Connect, we thought that basically we could leverage our network. We own a quite wide network of private connectivity. It's based on 650,000 kilometers of cables, submarine and terrestrial cables. And we put in place private connectivity from the mobile devices, from the mobile network, sorry, to the cloud applications. So the idea here is to remain in a fully private environment in order to make sure that the data crosses only places that we believe are safe, and in order to make sure that this service that you want to render with your IoT device remains safe. Again, I don't want to bother you too much with the product. I'm happy to have more demos and more explanation on our booth. We have our booth in 206 just behind there. Maybe what we want to do is to have a bit more discussion around the use cases that we put in place. So I'm going to have a few use cases here that I want to talk about. The first one is the banking. So we have, sorry for the, you may not see a lot, but the first one is the banking. So we put in place private connectivity for ATM machines. You may be surprised, but actually a lot of ATM machines are still connected through internet with VPNs, but again, unsecured. So we worked with a bank, I can't say the name here, but we worked with the bank and discussed on how we can put in place a fully private network from the edge SIM device, so from the edge device, up to the banker's service, to the bank's service. So this service is enabling to connect the ATMs in a fully private manner, in a secured environment, without being exposed to all those attacks that we can fear over internet, especially DDoS, especially the hacks in itself. So that enabled the banks to very rapidly expand their network of ATMs, and maybe sometimes also to avoid to have physical connections to the ATMs. Another use case that we had, because we were talking about health before, is a partner of ours that wanted to connect devices that are monitoring some patients' health details, and they needed to have a very private environment again. And they needed to make sure that the data that is transiting doesn't cross a public network and remains in a safe environment. So here we were able to connect a lot of devices to different cloud environments. This specific customer had a challenge because he needed to connect to various cloud environments. It was AWS, Azure, and Google Cloud, sorry, environment. Depending on which service was rendered, it wasn't running on the same services. So we were able to ensure the safety of the data from end device to the cloud applications and making sure only those cloud instances were accessible. That was another use case that we put in place as a POC. Another one was the retail point of sales, you know, those equipments where you pay with your credit card. Again, the banks, and here the credit card company wanted to remain in a private environment. So we were able to remain in a private network from the edge SIM device, so from basically the payment device, back to the bank credit card service, and ensure that all payment transactions remain on the private environment without being exposed to public internet at all. So I want to insist on the fact that it does not cross internet at all. It's not a VPN that creates a tunnel over a public network. It's really a private network. We have connections all across the world with 600 plus mobile operators that enables to have good coverage almost everywhere. In that specific case, the customer or the bank, the credit card company, wanted to have one single SIM that would work in lots of different countries. So the SIM in itself is not moving every day, but they wanted to make sure that whenever they're sending a SIM, it's also working in other places, basically, in other countries. Another one, because we are a company that per our DNA as a network company, we initially wanted also to enable fast remote sites connections. And again, some companies wanted to remain in their own private network, connect some of their remote sites to AWS servers or to Azure servers. But also, as you can see on the lower end, they wanted to go back, to have their traffic to come back to their own private clouds, to their own private places. We were able to provide that with this Edge SIM product, again, ensuring that we remain on the customer's private network. A last use case I wanted to walk you through is the famous automotive one. In the automotive environment, a lot of VPNs are put in place. So the automotive car manufacturers are big enough to talk to all the MNOs and have VPNs from the P gateways, the P gateways on the mobile side, up to their telemetry or infotainment servers. But that creates, I would call that a huge spaghetti of VPNs. And we were talking about how to migrate. If they want to change their infotainment servers and they want to change the locations, or maybe sometimes change some, so when a vehicle is changing from one country to another, it became a nightmare, very complex to put in place. We simplified that with, again, our solution, putting in place the SIM to be connected on a private environment, no need for VPNs anymore, no need to put in place any complex routing. Our routing is a layer 3 private environment, and the customers, the vehicles were able to connect very simply to their infotainment, wherever the car is actually located. So in a nutshell, what I wanted to really highlight here is that private IP is required in a subset of IoT devices, maybe the critical ones, but also in some cases, it's a good way to simplify really how you manage the connectivity from the edge device to the cloud applications. I'm happy to bring you to our booth here in 206 and give you some demos. We have some places to do the demos and explain a bit more, but maybe you guys have a few questions, and I'm happy to answer them right now.
Hello, Michele from Cargill here. Thanks for the presentation. I have one question regarding use cases. Did it ever happen to you to have a case in which local network was not available or was not reliable? And if yes, how did you address it?
So you're referring to the mobile network, the local mobile network?
Yeah, if mobile operators were not present in that specific area.
That is a challenge that we are facing indeed. So for now, we do not have a clear answer to that, but we're working very closely with satellite companies. So there is more and more satellite based connectivity that is getting out, based on LTE, 4G basically, but with low orbit ways. So for now, this is still experimental at our side, but that's how we can tackle this kind of use case indeed.
Thanks.
Thank you.
Thank you so much, everyone. Thank you so much, Sylvestre. A huge round of applause for the speaker.
Thank you.